Hello, niece and nephew. Today we're gonna talk about network layer in computer networks. This is a chapter 4. We are halfway through this journey. Okay, let's go. Here is the outline of chapter 4. 1. Introduction. 2. Network layer protocols. 3. Unicast routing. 4. Multicast routing. And 5. Next generation IP. Here are objectives of chapter 4. First, we discuss services that can be provided at the network layer. We then discuss the network layer at the TCP/IP suite. We then concentrate on the unicast routing and unicast routing protocols. We then move to multicasting and multicast routing protocol. And we finally discuss the new generation of network layer protocols, IPv6 and ICMPv6. In figure 4.1, show the communication between Alice and Bob at the network layer. This is the same scenario we used in chapter 2 and 3 to show the communication at the application and the transport layers respectively. And here is communication at the network layer. Wow. Before discussing the network layer in the internet today, let's briefly discuss the network layer services that in general are expected from a network layer protocol. It's have packetizing and routing and forwarding, error control, flow control, congestion control, and quality of service and security. Here is a figure of forwarding process. From the discussion of routing and forwarding in the previous section, we infer that a kind of switching occurs at the network layer. A router in fact is a switch that creates a connection between an input port and an output port, just as an electrical switch connects the input to the output to let electricity flow. The connecting devices in a packet switch network decide to route the packets to the final destination. Two different approaches to route the packets: datacam approach and virtual circuit approach. Datacam approach and virtual circuit approach is setup phase and data transfer phase and teardown phase. Here is a connectionless packet switch network. Okay. This is forwarding process in a router when used in a connectionless network. Here is a virtual circuit packet switch network. Okay, let's go. This is forwarding process in a router when used in a virtual circuit network. In the virtual circuit approach, the forwarding decision based on the value of the label of the packet. This is how sending request packet in a virtual circuit network. This is how sending acknowledgement in a virtual circuit network. And this is a figure of flow of one packet in an established virtual circuit. The upper layer protocols that use the service of the network layer expect to receive an ideal service, but the network layer is not perfect. The performance of a network can be measured in terms of delay, throughput, and packet loss. We first define these three terms in the packet switch network before we discuss their effects on performance. And here is a topic of network layer performance, delay, throughput, and packet loss. Here is a figure of throughput in a path with three links in a series. Here is a figure of a path through the network backbone. Here is a effects of throughput in a shared links. In chapter 3, we discuss congestion at the transport layer. Although congestion at the network layer is not explicitly addressed in the Internet models, the study of congestion at this layer may help us to better understand the cause of congestion at the transport layer and find possible remedies to be used at the network layer. Congestion at the network layer is related to two issues: throughput and delay, which we discussed in the previous section. Here is a topic of network layer congestion control. Here is packet delay and throughput as functions of load. Here is a figure of back pressure method of alleviating congestion. And here is choke packet, a packet sent by a node to the source to inform it of congestion. The warning is from the router directly to the source station. The intermediate nodes are not warned. Example ICMP. In our discussion of forwarding and routing, we represented a router as a black box that accepts incoming packets from one of the input ports, uses a forwarding table to find the output port from which the packet departs, and sends the packet from this output port. In this section, we open the black box and look inside. However, our discussion won't be very detailed. Entire books have been written about routers. We just give an overview to the reader. The structure of the router is components. It have input ports, output ports, routing processor, and switching fabrics. Here is a figure of router components. Here is input port. This is figure of output port. Here is crossbar switch. Here is banyan switch. And this is example of routing in a banyan switch. And the last is batcher banyan switch. The problem with the banyan switch is the possibility of internal collision. By sorting the arriving packets based on their destination port. Here is summary of this chapter 4. The internet is made of many networks connected to connecting devices, each of which acts as a router or as a switch. Two types of switching are traditionally used in networking: circuit switching and packet switching. The network layer is designed as a packet switch network. The network layer supervises the handling of packets by the underlying physical networks. The delivery of a packet can be direct or indirect. Two categories of forwarding are defined: forwarding based on the destination address of the IP datagram, and forwarding based on the label attached to an IP datagram. Okay, here is a summary of this chapter, and see you next time. Bye bye.